This session is for OCR FP1. The topic is series, and we're going to do January 2011 question 10. So let's start by having a look at the question. So in part 1, we're asked to show that 1 over r minus 2 over r plus 1 plus 1 over r plus 2 is equivalent to 2 over r upon r plus 1 upon r plus 2. And in part 2 it then says, hence find an expression in terms of n for the sum from r equals 1 to n of 2 over r upon r plus 1 upon r plus 2. And then in the last part we're asked to show that the sum from n plus 1 to infinity of 2 over r upon r plus 1 upon r plus 2 is equal to 1 over n plus 1 upon n plus 2. So 3 parts to have a look at, so let's start by doing this first part. So we need to take these 3 single fractions on the left hand side and find a common denominator and see if we can make it the same as the right hand side. So we have 1 over r minus 2 over r plus 1 plus 1 over r plus 2. So we'll take a common denominator of r upon r plus 1 upon r plus 2. So r into that will go r plus 1 upon r plus 2 times. And then r plus 1 into that will go minus 2 upon r plus 2. And then the last term, r plus 2, will go into it r upon r plus 1 times. And so we end up with this expression. So we need to simplify the numerator. So we have an r squared plus a 3r plus 2. Then we have a minus 2r squared minus 4r plus r squared plus r. And that is all over the denominator of r upon r plus 1 upon r plus 2. So all we need to do now is just to check. So we've got an r squared and a minus 2r squared and another r squared there. So they definitely do cancel out. 3r and another r, that's 4r, take away 4r. So those also cancel out, and we're just left with what we were hoping we'd be left with, which is a 2, and so we have our result. So there were 2 marks for that. There was 1 mark for taking the correct denominator and getting the numerator here, so 1 at this stage here, and then there was another accuracy mark for showing it correctly. So if we go into part 2, it says, hence find an expression in terms of n for this sum. Now we need to make sure that we understand when it says hence, we want to use the result that we've just established, and I've just put that result up here. So when we're doing this, we're going to split it into and say that it's the same as finding the sum of 1 over r minus 2 over r plus 1 plus 1 over r plus 2. So that's really the important thing. Again, this is going from 1 to n. So I'm going to do this now using a method of differences. So if we take r equals 1 first of all, then we'll get a 1 over 1 for our first term when I substitute it in here, minus 2 over 2, and then a 1 over r plus 2, which will be a 3. So I'm writing those terms sort of reasonably far apart so that we can see what happens as we progress. So when r is equal to 2, we'll get 1 over 2, and then we'll get a minus 2 over 3, and then we'll get a plus 1 over 4. And we just need to keep going until we can establish a pattern. So when r equals 3, we've got 1 over 3, then minus 2 over 4, and a plus 1 over 5. And I'll do one more term. I think we might be getting to the stage where we can see what's happening. So we've got a quarter minus 2 over 5, and then we have a plus 1 over 6. So we need to do the first few terms, and then we'll need to look at some of the terms towards the end. So if we take r equals n minus 2, we'd get 1 over n minus 2. We'd get a minus 2 over n minus 1, and a 1 over n, which is positive, so all these are positive. And I'll do the same now for r equals n minus 1. So that'll be minus 2 over n, and that will be 1 over n plus 1. And then the last term, r equals n, will be 1 over n, just squeezing it in a little bit here, minus 2 over n plus 1, and 1 over n plus 2. I put plus signs in before, so I'll just put the plus signs in again. So at that stage now, we should think, it's sometimes called the telescopic method, and the reason is because, of course, what happens now is that things start to cancel out. So you should see here that we have a third and another third here, and they'll cancel out with the minus 2/3, and the quarter and the quarter and the minus 2 over 4, and so on. So we can see, presumably, that these are going to cancel out. So nothing seems to be happening here with these terms, so these are going to be important in our sum. And as we go through it, the same sort of thing, this will have cancelled out, as will these, and the 1 over n and the 1 over n cancels out with the minus 2 over n, and again we seem to have 3 terms here. So it's important, actually, if you've done lots of these, to see that if you have whatever sort of shape you have here at the top, sort of triangle, 3 terms, you'll have the same sort of thing at the bottom. So what we're left with is we've got a 1, and then a minus 1, and a half. And then down here we've got a plus 1 over n, plus 1. We've got a minus 2 over n plus 1. And we've got a plus 1 over n plus 2. So hopefully you can see that that is going to be our sum. So the 1 and the minus 1 cancel out, and we're left with a half. 1 over n plus 1 minus 2 over n plus 1 is minus 1 over n plus 1. And then we have a plus 1 over n plus 2. And this now is going to be our sum. So our sum is going to be equal to that. So there were 6 marks for that question. So if we just have a quick look to see how those marks are awarded, then you do get a method mark for showing that you're going to use this idea of differences. So there's a method mark for using the differences. There's a method 1 mark for at least 3 terms at the beginning. Now I think you almost need 4, but they give you a mark for having at least 3, and another mark if you get the first 3 correct. And then in terms of the end, you get an accuracy mark for the last 2 terms, and a method mark for showing your cancelling, and an A1, an accuracy mark for it all being correct. So I'm just writing that out so that you can actually see where the marks are, the sort of thing that the marks are awarded for. And if we then just have a look at this last part, so this last part of the question, what it asks us to do is it asks us to show that the sum from n plus 1 to infinity of this series that we've just been looking at is equal to 1 over n plus 1 times n plus 2. So this is quite important that we see that what we're going to have to do is we're going to find the sum from 1 to infinity of this, which is r plus 2. So we need to find the sum to infinity, and from that we're going to have to subtract the sum from 1 to n. So that's the important, and it's a technique that is quite often required in these sort of questions. So that's the important bit about it, and that is going to give us the required sum. So that will give us the sum from n plus 1 up to infinity. That's what we need. So let's just think about what's going to happen here. So if we take this sum and we find the sum to infinity, so as n tends to infinity, so that means it's getting larger and larger and larger, then that means that a half minus 1 over n plus 1 plus 1 over n plus 2, each of these terms are going to tend to 0. So that, as that tends, is going to tend to a half. So going back to this, we're going to then have a half minus the sum that we had from 1 to n terms, which was a half minus 1 over n plus 1 plus 1 over n plus 2. And that means you can see what's happening, that the halves cancel out and you get 1 over n plus 1 minus 1 over n plus 2, and if we take a common denominator of n plus 1 upon n plus 2, and you can see from the answer that we're going to need to do that, we'll end up with an n plus 2 minus n minus 1, which gives us our required answer. So there were 3 marks for that bit. So if we just look at how those 3 marks are recorded, you're getting a mark for seeing that the sum to infinity has to be B1. You're getting a method mark for subtracting the sum to n terms, and you're getting an accuracy mark for getting the final answer in the correct form. So don't forget that if you want to watch more revision videos, then you can do so by following the link to the Further Maths support programme and using that.